The next technique that we will talk about is called condition coverage. Let's see this code. Read x, read y. If x equals 0 or y is greater than 0, make y equals y divided by x. Else, x equals y plus 2. Print x, print y. Let's try this code in Python, but let's solve it using decision coverage. So we will write the code and try to achieve 100% decision coverage on this code. So here x equals input enter first number and y equals input enter second number. If x equals 0 or y is greater than 0, y equals y divided by x. Else x equals y plus 2. Then print x, print y. Here there is a syntax error, so it should be x equals 0. Let's run, no problem. Enter first number. So let's try these two test cases. X equals 5 and y equals 5, and x equals 5 and y equals minus 5. Let's trace them. So x equals 5 and y equals 5. The first if, is x equals 0? No. Is y greater than 0? Yes, y equals 5. Then we will execute this line of code. And the second test case, x equals 5 and y equals minus 5. Is x equals 0? No. Is y greater than 0? No. So we will go to the else statement. This is 100% decision coverage. Let's try this on Python. First number 5, second number 5. He printed x and y, and he changed y because y equals, like we said, y divided by x, so it equals 5 divided by 5, which is 1. Let's run it again. Let's try x equals 5 and y equals minus 5, then minus 3 and minus 5. Y is minus 5 like we gave it to him, and x equals y plus 2, which is minus 5 plus 2, which means minus 3. So according to decision coverage, this code should be bug free. There are no bugs or issues in this code. But is this true? Is this correct? What if x equals 0? Let's try this in Python. Run. X equals 0 and y equals 5. When I press enter, this code should give no mistake. Why? Because we tried all the decision outcomes in this code. But there is an error. Why? He said 0 division error. Because y equals y divided by x, and here x is in the denominator. So what does this mean? This means that in some cases decision coverage is not enough. Okay? So this is why we need condition coverage. Condition coverage tests each condition in the true and false state. What is the difference between condition and decision? Decision is like this if, okay? If yes or no. But the decision itself can have many conditions inside it. This decision has two conditions, which are x equals 0 or y greater than 0. So what we should do in condition coverage, we test each condition itself in the yes and no case. Okay, so here x equals 0. This is a condition itself. Okay, so we should make x one time equal 0 and the other time not equal 0. Y greater than 0. This is another condition that we should test. So one time we try y greater than 0 and the other time y is not greater than 0. So these are the two test cases that we should use. One time x equals 0 and y equals minus 5. So here x equals 0 and y is not greater than 5. The second, x equals 5, which is not 0, and y is greater than 0. This will discover the error, and here in this case the developer should solve it. So let's solve this. If number of books is greater than 8 or sum is greater than 100, then extra discount. How many test cases are required for condition coverage? So we have two conditions inside this if statement. Number of books is greater than 8 or not. Sum is greater than 100 or not. So we should use two test cases. The first, for example, number of books is greater than 8, maybe 10, and the sum is greater than 100, maybe 150. And the second test case, number of books is not greater than 8, 5, and sum is not greater than 100, which is 50, for example. Like we said, we care about each condition itself, not about the whole decision.